Welcome. In this video, we're going to tackle a coin weighing problem. So we have 12 coins. They're all identical, so they look exactly the same. Can't tell them apart just by looking at them. However, one is just slightly heavier or just slightly lighter than the others. We're supposed to find this counterfeit in 3 weighings on a pan balance. So the solution should be able to identify the counterfeit as being too heavy or too light. And as an extra challenge, we're going to try to do this in a non-adaptive fashion, which means after the first weighing, we can't change what we're going to do the second weighing. We have to have a plan for all 3 of the weighings. So let's draw our 3 scales now. Okay, so there's our 3 scales representing the 3 weighings that we'll have to do on the pan balance. Now we have to work on the arrangement of the coins. So let's start by labeling our coins 1 to 12. They all look the same, but we can still label them like coin number 1 and coin number 2 and so on. So let's label them now. Okay, so there's our 12 coins. I'm going to do something that I call the shifting trick to tell me how to put these coins on the scale. So the way that this works is you just place the coin in any way on the scale except for on the left, 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 or on the right, 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 or in the balance, balance, balance section. The balance section being the section over here. So I'm going to pick, say, for coin 1 to be on the left, and then coin 1 will be on the right, and then coin 1 will be in the balance section. This is just my random starting position. And then what you do to find coin 2 and 3 is you shift. So you shift around like a circle, like counterclockwise, like that. So that coin 1 would shift to the balance section for coin 2, and then 2 would shift to 3 right there. 1 would shift to 2, and 2 would shift to 3. 1 would shift to 2, and 2 would shift to 3. So what this does is places the coins on the scale so they all have a unique pattern. We need to make sure that they always have a unique pattern, and we also need to make sure that there's the same number of coins on either side of the scale, and we've done that successfully with these 3 coins. So let's label how the scale responds if coin 1 is the bad coin because it's too heavy. It would go to the left, the right, and then it would balance. For coin 2, it would balance and go to the left and then to the right. For coin 3, it would go to the right, and then it would balance, and then it would go to the left. Let's notice that this shifting trick, it shifts in the following way, so that an L would shift to a B, and a B would shift to an R, and an R would shift to an L. The same way that this diagram does. The L shifts to a B, the B shifts to an R shifts to an L shifts to a B shifts to an R shifts to an L, and so on and so on and so on, always in that pattern. Now, we also have to worry about when our counterfeit is too light. The ones that we wrote down so far, these combinations right here, are for when our counterfeit is too heavy. So let's write down the scenarios for when our counterfeit is too light. To do this, we have to switch the L's to R's and R's to L's. So for coin 1, it would be R, L, B. The B stays the same. For coin 2, it would be B, R, L. And for coin 3, it would be L, B, R. Now, we just need to repeat this process 3 more times, and we'll complete the problem. The only thing that we have to watch out for when we're adding a new shifting set, I call it, a new group of 3, is we have to make sure that we're not repeating any of the patterns that we repeated before. So to make sure that I'm not repeating a pattern, I know that all of my coins switched their position, left, right, and balance last time. So now I can maybe keep one of the positions the same. So I'll do like 4, and 4 stays the same for the first 2 weighings, and then maybe it switches to the right-hand side for the last weighing. And now I'll shift 4. So 4 shifts to 5, 5 shifts to 6, 4 shifts to 5, and 5 shifts to 6, 4 shifts to 5, and 5 shifts to 6. Now let's write down the responses that the scale gives if either coin 4, 5, or 6 is the counterfeit coin. Okay, now we'll repeat the process for coins 7, 8, and 9. So for coin 4, when we started this off, it stayed on the same side of the scale for the first two weighings. How about with coin 7, we'll switch it up so it stays on the same side of the scale for the second two weighings. So I'll put coin 7 in that pattern, and we'll shift. Coin 7 goes to coin 8 goes to coin 9, 7 goes to 8, 8 goes to 9, 7 goes to 8, 8 goes to 9, and now we'll write down the responses for those three. Okay, so there's one more grouping left for coin 10, 11, and 12. So what we could do here is place coin 10 on the same side of the scale for the first and the last weighing. We haven't done this grouping just yet. So this would produce coin 11 on the left when it switches, and 12 when it switches to the balance position. 10 shifts to 11 off of the scale, and 12 shifts to the right-hand side. 10 shifts to 11, and 12 shifts off of the scale. And write down the responses for these ones now. And that completes our solution. So some comments to note here. Notice that you can't use the left, left, left option as your starting point, or right, right, right option as your starting point, or even balance, balance, balance as your starting point. Let's say you had like coin A that you tried to put over here on the left each time. It would shift to coin B in the balance section, and then coin B would shift to coin C on the right-hand side of the scale. And notice that there's a conflict between coin A and C here. If we tried to say that the scale tipped to the left each time, and that's because of coin A, we wouldn't actually know that. It could be because of coin C maybe bringing the right-hand side up, or it could be because of coin A bringing the left-hand side down, and we wouldn't know the difference between the two. And furthermore, this option over here would cause a problem with our solution, because this particular question asked we're supposed to identify the counterfeit as being too heavy or too light. So if we leave a coin off of the scale each time, you don't find out if it's too heavy or too light. So we'll just leave our solution just like this, and maybe to play this out, to understand it a little bit more, let's just say we arranged our coins on the scale as the picture shows, and let's say the scale goes down on the first time, then maybe it balances the second time, and then let's say that this right-hand side comes down. So we would have the combination of it tipping to the left, and then it balancing, and then tipping to the right in this random example that I've just made up. So it would turn out that looking at our table, if we look through and find that combination, it's right here. That's left balance right. So that tells me that it must be coin 3, and it must be because it's too light as opposed to being too heavy. And you could do this with all of the other 12 coins as a possible outcome as the counterfeit. So this is a foolproof solution that no matter which of the 12 coins is counterfeit, you can find it and identify it. Thanks so much for listening. So this has been a summary of the shifting trick on how to produce a non-adaptive solution for 12 coins and 3 weighings.